This is our second lesson in Chapter 0, our 6th grade review. This lesson is going to be about comparing fractions. And this lesson has a lot of important stuff with fractions. So if you're not somebody who is feeling very confident about doing operations with fractions, this is a very good intro lesson to kind of review some things. So let's get right to it. First, I just want to talk about what is a fraction. This is not part of your note packet. I just want to do a very fast review. Remember that a fraction represents a part of a whole. So here we have a couple fraction models. Remember, fractions are split into numerators and denominators. The denominator, or the bottom number, is how many pieces our whole is split into. So if we look here, 1, 2, 3, 4, our whole is split into 4 pieces, so our denominator is 4. Of those 4 pieces, 3 of them are shaded green, so that model represents the fraction 3/4. So really quickly, let's go through the rest of these. Over here, if we count up all of the pieces in the whole, we get 8, so our denominator is 8. The green pieces, there are 5 of them, so that model represents the fraction 5/8. Down here, trust me, if you count up all of the pieces, there are 9 of them. And you will notice that all 9 are shaded, so that represents the fraction 9/9. And we would want to simplify that to one whole. And that makes sense because the whole thing is shaded green. Finally, we have this model, and there are 6 pieces. Of those 6 pieces, 2 of them are shaded green. Now both of these numbers are even, so I know I can simplify this fraction by dividing the numerator and denominator by the GCF, which is 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So my simplified version of this fraction is 1/3. And what that means is I could create this same picture, but instead of cutting my whole into 6 slices and shading 2 of them, I could cut it into 3 slices and shade 1 of them, and it would look exactly the same. Okay, there's our review of fractions. Let's jump into your notes. First note, to compare fractions, we must first find the least common denominator, also known as the LCD. Now, if you can't find the least common denominator, it's okay to at least find a common denominator. So always remember that. As long as our denominators are the same, then we can compare fractions. After we have our common denominators, then we are going to compare fractions by looking at their numerators. So the numerators are the important piece once the denominators are the same. So here's our first example, 5/12 and 4/9. We're trying to compare them. We're going to use greater than, less than, or maybe equal to, who knows. So we're going to try to figure out which one of those symbols is the correct one to go in there. And I'm going to jump to the next slide really quickly because I want to review how to find the LCD really, really fast. So there are 2 methods in doing this. The first method is the listing method. The second is the prime factorization method. Both are excellent. Prime factorization works a little better when you've got really, really big numbers. Listing works better when you have small numbers, so you can kind of use these interchangeably. The listing method is when we start off by listing multiples of our 2 denominators. Now, to find a multiple, remember we take our number and we multiply by 1. And then we multiply by 2. And then we multiply 12 by 3. And then we multiply 12 by 4. And then we multiply 12 by 5. Until we have a little bit of a list kind of going on here, and we say, okay, we've got 5 multiples. Hopefully my LCD is somewhere in that list. Now we do the same thing for the 9s. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Well, it looks like I have found my LCD, 36. Now, the other reason students like to use this method, besides for the fact that it's very, very easy, is that we can use our list to help us figure out what number we need to multiply our fractions by in order to get those common denominators. So, my fraction that has the denominator of 12, I'm going to multiply that by 1, 2, 3. because 12 times 3 gets me 36. My fraction that ends in 9, I'm going to multiply that by 1, 2, 3, 4, because 9 times 4 is 36. So that's a really nice method there. That gets us set up for what we have to do to solve our problem. Really quickly, let's take a look at the second method, the prime factorization method. Prime factorization is when we write numbers as little multiplication problems, and we stop once we have figured out all the prime factors that need to be multiplied together to get us the number. So we start with the number 12. 12 can be written as 4 times 3. 3 is already a prime number, so I'm going to circle it and stop on that branch. 4 is not prime, we call that composite, so we can rewrite that as another multiplication problem. 2 times 2, and 2's are both prime, so we can circle them and stop. So our prime factorization of 12 is 2 times 2 times 3. Notice we're going to put those numbers in ascending order. Now we're going to do the same thing for 9. 9's even faster. Okay, 9 can be written as 3 times 3, and we know that both 3 and 3 are prime numbers. So the prime factorization of 9 is 3 times 3. Pretty quick. Now we want to use a Venn diagram. And we're going to put our factors into this Venn diagram. I'm going to put 12 over here, 9 over here, and as you know, the common factors get put in the middle. Okay, just like any Venn diagram, what's shared goes in the middle. So let's look at my two lists here. 2, 2, 3, 3, 3. We see that we have a 3 here and a 3 here. I'm going to cross them out, and I'm going to put that shared 3 in the middle. Nothing else is shared between my two prime factorizations, so I go to my 12 list, and I put the two 2's on the 12 side, and I go to my 9 list, and I put the extra 3 on the 9 side. Now to find the LCD, we're going to take the numbers inside the diagram, and we're just going to multiply them together. 2 times 2 is 4, times 3 is 12, times 3 is 36. Both of these methods work. Like I said, the prime factorization works a little better when we have big numbers. The listing works a little better when we have small numbers. But either way, we got the same common denominator, 36. So let's bounce back to our problem here. We need to turn both of these fractions into something over 36. And if you remember from the listing method, we figured that we would have to multiply our 12 fraction by 3, because 3 times 12 is 36. And if we multiply the denominator by 3, then we have to multiply the numerator by 3 as well. And that gets me 15/36. These are equivalent fractions. They mean the same thing. They're just written in different ways. Now we jump to the 9th fraction. We know that 9 times 4 is 36, so we have to multiply our numerator by 4 as well to keep our fractions equivalent. 4 times 4 is 16, so our equivalent fraction is 16/36. Now that we have common denominators, we use our numerators to help us compare. And 15 is smaller than 16, so I'm going to use the less than sign. So instead of a question mark, that should be a less than. All right, I'm going to skip ahead here to one more practice problem. One last example. This says to put the numbers in descending order. Remember from our previous lesson, descending means we're going greatest to least. Okay, greatest to least. So I'm going to start with my biggest numbers here. And when I look at these 4 numbers, I can see that I've got 2 that are positive and 2 that are negative. So we know that positive numbers are larger than negative numbers, right? So I'm going to start with my positives, 8 and 4/5, 8 and 9/12. My common denominator here is going to be 60. Now I know that because I've been doing this a long time, but we could do our LCM listing methods or our prime factorization method to figure that out. 5 times 12 gets me 60, so I have to multiply the numerator by 12 as well. That gets me the fraction 8 and 48/60 here. Over here, I'm going to multiply 12 times 5 and 9 times 5 to make my fraction equivalent. That gets me 8 and 45/60ths. I can see that 48 is greater than 45, so my biggest fraction up there is 8 and 4/5. Always remember, we are writing our original numbers in our final answer. That means 8 and 9/12 comes next. You might be tempted to simplify that 9/12, but do not, because it's the original number calls for the unsimplified version, okay? All right, now we're going to switch colors. We're going to talk about our negatives. I have -6 and 1/2, -6 and 3/7. Remember, with negatives, the rule gets flip-flopped. If it looks bigger, it's actually smaller because it's farther away from 0 on the number line. I'm going to multiply by 7 here because my common denominator is a 2, or it's 14, pardon me. I'm going to multiply by 2 here to get that common denominator of 14. That gets me -6 and 7/14, -6 and 6/14. Okay, 7 looks bigger than 6, but since it's negative, that guy's going to be farther away from 0. So my bigger of the two here is actually -6 and 6/14. And I'm going to write that back in its original format, -6 and 3/7. And -6 and 1/2 is the smallest. Okay, notice I line my numbers up right underneath so I don't get confused. I show all my work, and then it's easy for me to kind of pop back up and put the original number in my final answer, for my final answer form. Okay, great job today. See you tomorrow.